Alright guys, so this is the finished program. It's 123 lines of code, and it's made with HTML, CSS, and JavaScript. And yeah, so basically right now I'm just going to explain how this program works, and I'm just going to go through the code and explain most lines in the code. So yeah, let's get started. So this program, its objective is to test how good your decision making with, checking if a color is black or white, like more black or more white. Like this is pink, or like dark pink, I don't know, and like it's kind of hard to see if the color is black or white, which is why I made a neural network that, it's more accurate with a neural network because it doesn't have any opinions or anything, and only makes its decision based on its learning and with facts. But we have like our own opinions and stuff because we're living beings and stuff. So yeah, let's get started. So the moment I click this button, start training, it's like you didn't see it because it was pretty fast. You can see it in this part of the code. Where is it again? 4. I'm just trying to find that part of the code. Yeah, this part. Yeah, right up here. So it ran this. No, wait, what wasn't this? Was it? It was, yeah. Sorry, it was this. There we go. So it ran this for loop 100 times, and it changed this color 100 times, and then what it did, it put all of its data into this data array. Okay, and you can see if I console.log this data array, you can see. Let's just get the first color change. So the first value is R divided by 255. So it's like a percentage of how much red there was out of like the maximum amount of red, which is 255. So over here, that would be like 0.226 times 255. So over here, that was actually 57.63 red. But since this neural network can only process 0 to 1, I put it divided by 255. But that's so yeah. So it's like a fraction or a decimal out of 255. And then the next one is G, and then the next one is B, and then the next one is 0. 0 means that it's closer to black than it is to white. And how did I calculate that? You can see over here. If the red plus green plus blue is bigger than 255 times 3 divided by 2, it's like half of the maximum value, then it's more white. But if it's smaller than half of the maximum value, then it's more black. And that makes quite a lot of sense, I hope. And yeah, so that's how I determined the output. And white is 1 and black is 0. And then after that, I put all the data in the neural network. You can see that over here, n.train data. Yeah, I just like formatted the data array, and I made like a new array, but that's fine. You can see inputs, this RGB, and then this is the output. And then after that, I made some, yeah, and then there's like the final output message. So let's do this again. Okay, ready? Start training. So it ran this thing 100 times, and it changed the color 100 times, and it knows it has the data, but the neural network hasn't learned it yet. So if you click start next process, and then this is the new color. It's purple. Is this color more white or black? Well, the neural network, we're actually not supposed to see this because then like we're kind of cheating. The neural network is quite sure that this color is more white, because 0.9999, and that's really, really close to white. Okay, and just saying, because this is a sigmoid function, I'll have it up on the screen just in a second. You can see that it actually never touches 0 or 1. It's like it's called an asymptote in math. It never touches the number. It just approaches it, but never touches it. Okay, so is this color more white? We cheated, so white. Okay. Oh yeah, and there was like a glitch over here. It actually never outputs all this, so I have to manually do it myself. So output message. Correct. You thought this color was more white. Okay, that's correct. According to the neural network, there's a 0.99 blah 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 chance certainty that the color was more white. Okay, but let's do this again without seeing this. Okay, so I'm actually gonna take this out. So now it has all the data, but hasn't learned it yet, so I'm gonna make it learn. This is quite black, so I'm gonna write black. Okay, black. What? Oh yeah, right. And then we have to run the function. Correct. You thought that this was more. Okay, well then. Okay, whatever. Correct. You thought that this was more black. According to the neural network, there's a 0.9 blah blah blah, and that the color was more black. So yeah, that was correct. I'm just gonna remove this because, yeah, I don't think it works. Whatever. So let's do this final time. This is yellow. Start training. Start next process. This is white, I would say. What does the neural network say? Correct. You thought that this color was more white. According to the neural network, there's a 0.9 and blah 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 chance/certainty that the color was more white. So I'm just gonna do this a final time. Start training. Start next process. This is white, obviously. Okay. Oh, that could be black. I don't know. Yeah, wrong. Yeah, I thought it was black. But yeah, you thought the color was more white, but it was more black. According to the neural network, the neural network is quite smart. It's really sure about its answer. So yeah. Thanks for watching, and if you have any questions, feedback, or anything like that, please leave it in the comments below. See you guys next time.